Hello everyone. So you should have taken your Unit 2 test by now, and if you're up to this point, you are ready to start Unit 3. Unit 3 is about systems, and we're going to start with linear systems. So linear means something that makes a line. We've graphed lines in Unit 2. We're going to be graphing linear systems. Now, a linear system is basically more than one linear equation at the same time. So graphing two lines at the same time. The goal is to find the point where oh my gosh, I can't believe I did that. Roast me in the comments. Where two lines intersect. The goal is to find the point where two lines intersect. This point is called the solution to the system. It's the pair of numbers that satisfy or work in both equations at the same time. So if you can plug a number into an equation and it actually works, that's called a solution. On a graph, xy, you've got two numbers, right? The x-coordinate, the y-coordinate. So something like 3, 5 or -8, 2. A solution is something where you plug both numbers into both equations and they both work at the same time. Some systems have no solution, that is, they do not intersect. And some systems have an infinite number solution, that is, both lines are actually the same line. Okay, we'll get to examples of all of this. I don't want to dwell on this explanation up here. Number 2, I'm going to work out slow and explain every last little detail. Number 4, I'm going to streamline it a little bit and get into a system that you can use quite regularly. In fact, I'm going to do number 2 twice. Ooh, sounds exciting. Yeah, so here goes. So I'm going to first graph these by hand. So let's say we've got y equals x minus 2. So -2 is the intercept. The slope is a 1, which you treat as up 1 over 1. So that gives me a line that looks like this. The second equation, let me erase that, has an intercept of +3. The slope is -4. You think of that as -4 over 1. So down 4 over 1, down 4 over 1. It's a line that looks like this. Here is where those two lines intersect. The coordinates of that point, 1, -1. 1, -1 is the solution. Here's what that means. If I go to this equation and I plug in, remember x is 1, y is -1. If I plug those in, I get -1 equals 1 minus 2. If I work that out, 1 minus 2 is -1. It balances. It checks. If I do the other equation, -1 equals -4 times 1 plus 3. That's -1 equals -4 plus 3. -1 equals -1. That balances or checks out. So this is the only point that works in both equations at the same time. If I picked any other point, let's say I pick this point. That point is going to work in this equation, but it's not going to work in the other one because it's not on that line. If I were to choose, let's say, this point right here, that point is going to work in this equation, but it's not going to work in that one because it's not on that line. And if I chose this point and plugged them in, it wouldn't work on either line. It doesn't satisfy either equation because it's not on either line. So by graphing these and finding the intersection point, you're finding the coordinates of the point that satisfies both equations at the same time. Now, why am I erasing all of this work up here? Because you don't have to do that. I did it to sort of explain what the solution is, to give you an algebraic sense for what we have found. But what you're expected to do is simply draw the graph and indicate the point where they intersect. Now, I said I would do this equation or this problem twice. The second time I do it, I'm going to use Desmos. All right, so look at this. There's a bunch of pre-calc on the screen. I just got done teaching logarithms. I'm sure you don't want to deal with that right now, so let me eventually delete all this. All right, let's type these in to Desmos. Y equals x minus 2. So there's that line. And y equals negative 4x plus 3. And where's the point where they intersect? 1, negative 1. Now, I do want you to still draw that over here, and I want you to write down the answer. But you can use Desmos to help you out. Just for overkill's sake, let me check the answer, and there it is. There's the graph. There's the solution. All right, so do you understand what's expected of you? Let's look at number 4. Now, number 4 is going to be kind of special. Y equals negative 7 halves, oops, not 72, 7 over 2, x plus 4. And, all right, so let me actually draw that. So, right there, and right about there, and I get a line that looks sort of like this. That's pretty bad. I can actually move it a little bit. Maybe not. Maybe I'm just not. There we go. So there's that line. Now let's type in the other one. Y equals negative 7 halves x plus 2. And I get this line in green here. It looks kind of like this. Okay, my poor art skills notwithstanding, that's roughly what it looks like. And do you see that those two lines are parallel? And this reaffirms what we learned in the last unit, that parallel lines have the same slope. So there's my graph. Now, if the solution is the point where they intersect, or the point where they cross, and these lines don't cross, what does that mean about the solution? It means there is no solution. Or you can use that null set symbol, whichever you prefer. So number 4 should be a graph of parallel lines and no solution. There it is. So that can happen. That's one of our special cases. You can have no solution. Number 6. Are these two parallel? No, clearly not. They do not have the same slope, so they're not parallel. So y equals 1/2, not 12, 1/2 x plus 2. And then on the second line, y equals 2x minus 1. All right, the first line, see, has a y-intercept at 0, 2. Oop. And it goes through the point 2, 3. It looks kind of like this. The second line has a y-intercept 0, negative 1, and it also goes through 2, 3, so it looks kind of like this. Maybe not so crooked. And then clearly the point where they cross each other is 2, 3. Check number 6. And we're good. So this is going to be an easy assignment, huh? You can probably just burn right through this. Yay. All right, next one is written in standard form instead of y equals mx plus b form, but that shouldn't matter at all. X minus y equals 1, and x minus 4y, oops, x minus 4y equals negative 8. Here are our two lines, 0, 2, and why do I always have the highlighter on? 0, 2, and 4, 3. So here's this line. And then the next one, all right, that's crooked, but I don't really care a whole lot. Looks kind of like this. And man, I'm just not doing well. Okay, we'll call that good enough. And the point where they cross, 4, 3. Do you think you can do this? There we go. I wouldn't stop just yet because we do know there is a few special cases, and we've only encountered one of them. So I'm going to keep going if you are. 2x minus y equals 2. There's one line. Let me go ahead and graph this first. And using these key points can help you get a quick, accurate graph. The second graph, y equals 4. Do you remember what that type of line is when it has a y but no x? Y equals 4. Horizontal. Horizontal right through here. And you can see they cross at 3, 4. But if you tap your screen, it tells you 3, 4. So number 10. Sorry, getting ahead of myself. There it is. Horizontal line. Yep, graph. Everything looks good. Next one. X plus 2y equals 8 and 3x minus y equals 3. All right, let me graph these. 0, 4, 2, 3. There's one line. The next line has an intercept at 0, negative 3, 1, 0. And obviously they cross at 2, 3, but if it's not obvious, you tap the screen and it tells you there 2, 3. So number 12, are we looking good? Oops. Yes, we are. Okay, number 14. Ooh, pretend you didn't see that. All right, let's type these messes into Desmos and see what happens. 0 equals 1 minus 1/6 x plus 1/2 y. So that is this line, 0, negative 2, 6, 0, which is way over there. Wow, I messed that all up. Let me drag this down. There we go. That's a little better. So there's this line. Now let's type in the second one. 6 minus x equals negative 3y. Well, what just happened? There's the blue line. There's the green line. It's the same line twice. How do you graph the same line twice? Well, I guess you could just draw it a second time. If you're using your iPad or you have pens, you could change the color. But yeah, it's the same line twice. So let's talk about this. The answer is the point where these two lines intersect. Intersect means touch. Where do these two lines touch each other? Well, they touch each other here, and here, and here, and there, and there, and there, and there, and there, and there. They touch each other infinitely many times. So we call this infinite solutions, or infinitely many solutions. There's different ways to phrase it, to word it. Infinite number of solutions there. There's another way to say it, but that's good enough. Okay, so this is the assignment. So you're going to be practicing using Desmos. You're going to be practicing drawing decent graphs. Do your best to make your graph look like it does on the screen of Desmos. You're going to be indicating the point where these two lines intersect each other. And that's about it. If you do have any issues, contact me through the normal means. Otherwise, I will talk